Hello students, I am Sumulata. In today's class, we are going to discuss about pH3 nothing but phosphine and chlorides of phosphorus and oxoacids of phosphorus. Along with this, you can able to watch previous lectures related to this topic. Those are introduction, physical properties, chemical properties, next dinitrogen, allotropes of phosphorus, ammonia, nitric acid preparation properties. Then continuation is today's topic. So try to watch complete video without skipping, then you will get more information that will really helpful for your examination. That's what I am saying you. After finishing watching of this video, just please mention your words in comment box. Is it useful or not? How do you feel about this lectures? And another one is these are really useful for you. Please do subscribe and share these videos to your known people and also like. Okay, then coming to our topic, here it is the pH3. pH3 is the phosphine. Phosphine is the colorless gas. It is having rotten fish smell. It is the colorless gas and a rotten fish smell. See, colorless gas and rotten fish smell. Okay, if this phosphine is if it is near to the strong oxidizing agents, like if those are in traces of amounts, that means if the phosphine is near to the traces of strong oxidizing agents like HNO3, Br2, Cl2 and some other oxidizing agents, then it will become explodes. That means phosphine will become explodes if it is near to the traces of amounts of strong oxidizing agents. Then coming to preparation methods of phosphine. Phosphine can be prepared by the reaction happens between calcium phosphide reacts with water and also calcium phosphide react with diluted HCl, then phosphine will be formed. See, this is the calcium phosphide Ca3P2. Ca3P2 is the calcium phosphide. I will write clearly. Ca3P2 is the calcium phosphide. If it reacts with water, then you will get 3 moles of CaOH twice and 2 moles of pH3 phosphine. So phosphorus number balanced. Then you can check about hydrogens number. Here 6 hydrogens, here also 6 hydrogens. So you need to take 6 water molecules. Then coming to next one, if the same calcium phosphide reacts with HCl, diluted HCl, then here also same CaCl2, 3 moles of CaCl2 will form and another one is 2 moles of pH3 phosphine will form. You can try to balance chlorine's number, 6 chlorine atoms, 6 hydrogen atoms, so that you need to multiply with 6 to the HCl. So now it is balanced. So here first one is calcium phosphide treated with water, you will get phosphine along with the calcium hydroxide. Okay, and another preparation method is same calcium phosphide reacts with diluted HCl, that will gives you also phosphine. This is one preparation method. Another preparation method, if you see, white phosphorus P4 is the white phosphorus treated with NaOH, hot NaOH or hot and concentrated NaOH, water also there, you will get phosphine. See, pH3 plus 3 moles of NaH2, NaH2, PO2, 3 moles of NaH2, PO2. This is the sodium hypophosphite. Sodium hypophosphite, this one. Okay, this is phosphine. See, all these are balanced or not? 3 2s are 6 plus 9. 3 2s are 6 plus 3, 9, balanced. Next, 6 oxygen atoms. 3 2s are 6 oxygen atoms, 4 phosphorus atoms, 3 sodium atoms. So it's balanced. Next one, if you see one more preparation method, if see, this is the pH4i, phosphonium iodide. Phosphonium iodide. This phosphonium iodide reacts with potassium hydroxide, KOH. Then it will gives you pH3, phosphine, potassium iodide and water. These are the preparative methods for the phosphine. Okay, preparative methods for the phosphine. You can see about chemical reactions of phosphine. Copper sulfate, chemical reaction. First you can write heading, chemical, CR nothing but here chemical reactions. Copper sulfate, 3 moles you can take, not calcium sulfate, CaSO4 you can take, calcium sulfate. This calcium sulfate reacts with phosphine. So you will get Ca3P2 and 3 moles of H2SO4. See, calcium phosphide, this is the calcium phosphide. In the same way, mercury chloride you can take. HgCl2 reacts with phosphine. HgCl2 reacts with phosphine. It will also gives you 3 moles of not 3 moles, Hg3P2, Hg3, mercury phosphide, and another one is 3 moles of, or not 3 moles, 6 moles of HCl. Yes, this is this reaction with the formation of calcium phosphide, this reaction for formation of mercury phosphide. And one more thing, it is slightly basic, so that it can, phosphine can react with acids also. So for that one you can take acids, HCl or HBr, HI, like that. So pH3 reacts with HBr, hydrogen bromide. This will gives you phosphonium bromide, PH4Br, phosphonium bromide, because of it is slightly basic, so that it will reacts with acids. Here instead of acid we are taking hydrogen bromide, so PH4 will be formed, PH4Br, phosphonium bromide. Okay, this is about preparation methods and chemical reactions. And if you see uses of phosphine, you can see uses, especially 2 uses. Those are, phosphine can be used in Holmes signal and also smoke screens. What is Holmes signal? What is smoke screens? If you, smoke screens are nothing but army people will use, because large amount of smoke will become just like a screen. So they are using, their phosphine going to be used. Coming to the Holmes signal. Holmes signal is nothing but, it is formed by the combination of calcium phosphide and calcium carbide. If you take these two, compounds going to be mixed in a container, and those containers thrown into the sea water. Then after, they will, after reacting together, with each other, those compounds will release as gases. Those gases going to be react with water, then they will release flame. That flame acting like a signal for the ships traveling on the sea water. Okay, you can see those reactions also. Here I am going to write. First one is Ca3P2. This is the calcium phosphide. Okay, calcium phosphide reacts with water, then it will gives you 3 moles of CaOH taken twice, calcium hydroxide, and 2 moles of pH3. So you can take 6 moles of water here. Now it is balanced. This is phosphine. This is the gaseous form, and you can take next one, calcium carbide. CaC2. CaC2 is the calcium carbide, react with water, then it will gives you CaOH taken twice and C2H2. This is the C2H2. Ethylene or acetylene, C2H2. This is also gaseous form and this is also gaseous form. These gaseous forms reacting with water, they will release smoke, not smoke, a flame. That flame acting as a signal for the ships traveling on the sea water. Okay, this is nothing but Herm's signal. HOLME', Herm's signal. Another use is what? Use like is on smoke screens. These smoke screens are used by army people. Phosphorus can form 2 types of halides. Those are PX3 type halides and another one is PX5 type halides. PX3 type halides, if you see PX3, here X is fluorine, chlorine, bromine, iodine. Another one is PX5 type halide. Here X equal to fluorine, chlorine, bromine only, not iodine. If you go to trihalides, especially we are taking example PCl3, phosphorus trichloride. This one is the phosphorus trichloride. This is the colorless oily liquid. Colorless oily liquid. Its shape is, see, Cl, this is the back of the plane, chlorine, and this is the front of the plane, another chlorine. This is the pyramidal shape. Its shape is a pyramidal shape. PCl3 shape is the pyramidal shape and it is in a sp3 hybridization shape is the pyramidal. Okay, then coming to next one, preparation methods. How phosphorus trichloride going to be prepared? First one, if you see, by passing dry chlorine through the overheated white phosphorus. By passing dry chlorine gas through the overheated phosphorus, if you white phosphorus, then you will get PCl3. See that reaction. This is the P4 white phosphorus and chlorine gas, 6 moles you can take. So 4 moles of PCl3 will form. This is the phosphorus trichloride. And another preparation method, if you see, here also P4 reacts with thionyl chloride. 8 moles SOCl2 if you take, this is the thionyl chloride. It will gives you PCl3, 4 moles of PCl3 and 2 moles of SO2 and 2 moles of S2Cl2. sulfur atoms not balanced, so that here if you take 4 moles of SO2, then it will be balanced. See, 8 sulfur atoms and 8 oxygen atoms, 4 2s are 8, 16 chlorine atoms here, 12 and 4 3s are 12, and this one is 16. Yes, 4 chlorine atoms, 16 chlorine atoms, so that it's balanced. Next one you can say about chemical reactions of phosphorus trichloride. Chemical reactions. Chemical reactions of phosphorus trichloride. If you see here, PCl3 reacts with water present in the moisture or air, then it will form H3PO3 along with this HCl also, 3 moles of HCl. H3PO3C, 6 hydrogen atoms, 3 chlorine atoms and 3 oxygen atoms, 1 phosphorus. And next reaction is phosphorus trichloride also reacts with organic molecules containing OH group. See those reactions also. If you take ethyl alcohol C2H5OH, ethyl alcohol having OH group here, see. So this ethyl alcohol reacts with phosphorus trichloride, then it will form ethyl chloride C2H5Cl plus H3PO3. See, listen. 3 C2H5 and 3 chlorine atoms. So you can write 3 here, and then remaining will be balanced. See, 1 phosphorus and 1 next oxygen atoms. How many? 3 oxygen atoms. Hydrogen atoms here, 3 hydrogen atoms removed from here, 3 oxygen atoms and 3 hydrogen atoms removed, so that H3PO4 will be formed. And the next reaction also, acids also containing OH group. If you take C2H5COOH, C2H5COOH, here it is also 3 moles, then reacts with PCl3. Ethanoic acid will gives you 3 moles of ethanyl chloride C2H5COCl. This OH will be removed out, not this O. So remember, so here also another product is H3PO3. These are the preparation methods and chemical reactions of phosphorus trichloride, and this is the structure, shape and hybridization. Then we will move to discuss about PX5 type halides, especially by taking PCl5, phosphorus pentachloride. If you take, then its preparations, properties we will see. Phosphorus pentahalide, PCl5. Phosphorus pentahalide, nothing but phosphorus pentachloride. Here instead of halide we are taking about chloride. So this is a phosphorus pentachloride. You can see preparation methods of phosphorus pentachloride. Here also white phosphorus reacting with excess of chlorine gas, then it will gives you PCl5C. Dry chlorine gas, excess of dry chlorine gas passed through the overheated white phosphorus, then we will get PCl5, phosphorus pentachloride. And another method here, the same white phosphorus reacts with sulfonyl chloride, SO2Cl2 is the sulfonyl chloride, this one is the sulfonyl chloride, then you will get PCl5 and 10 moles of SO2. See, listen, PCl5, is it balanced or not? 10 2s are 20, 4 5s are 20, 4 phosphorus atoms, 10 sulfur atoms and 20 oxygen atoms. Now it's balanced. These two are the preparation methods for the phosphorus pentachloride. And then coming to chemical reactions. Chemical reactions, if you see, this phosphorus chloride also reacts with water present in the moist air. See that reaction. That reaction takes place in two steps. PCl5 reacts with water. First, it will gives you POCl3, phosphorus oxychloride, and next one is 2 moles of HCl. And then after the formed phosphorus oxychloride again reacts with water. Here 3 moles you can take. Then it will form H3PO3. H3PO4 will form, not 3. H3PO3 and then 3 moles of HCl. H3PO3 is the orthophosphoric acid. This one, orthophosphoric acid. H3PO3 is the orthophosphoric acid. See, is it balanced or not? 6 hydrogens, 6. 3 chlorine atoms, 4 oxygen atoms. It's balanced. And remaining chemical reactions, if you see, same like phosphorus trichloride, it will also going to be reacting with organic compounds containing OH group. So you can see those reactions also. PCl5 reacts with C2H5OH. Then it will form C2H5Cl and then POCl3. See, these are the products. I think chlorine atoms are not balanced. Yes, POCl3. After that, what are the remaining one here? 1 hydrogen and 1 more chlorine. See, this here already 4 chlorines completed. So another one is HCl. Another molecule will be the HCl. See, phosphorus pentachloride reacts with ethyl alcohol. It will gives you ethyl chloride and phosphorus oxychloride and hydrochloric acid. And one more reaction, if you see, PCl5 reacts with ethanoic acid C2H5COOH. This is the carboxylic acid. Here C2H5COCl, ethanoyl chloride will form. Along with this, POCl3 and HCl will also form. These are the chemical reactions of phosphorus pentachloride. Then if you come, its structure is bipyramidal, trigonal bipyramidal shape, sp3 dehybridization. Bond angles are 90 and 120 degrees. You can see its structure. This is phosphorus, chlorine. This is also chlorine. See, chlorine. This is the trigonal bipyramidal structure. 90 and 120 degrees you will going to observe here, and sp3d hybridization. It is yellowish white solid with moist air. It is yellowish solid with moist air. Yellowish solid with moist air. This is about phosphorus trichloride and phosphorus pentachloride. Then we will move to oxoacids of phosphorus. Yes, oxoacids of phosphorus. If you see, oxoacids of phosphorus. First one you can see H3PO2. This is the hypophosphorus acid. Hypophosphorus acid. You can see its structure. This is phosphorus, double bond O, H, H and OH. This one is OH. The P double bond O, H, H, OH. Here, how many pH bonds are there? P and H, two pH bonds are there, and one P double bond O bond is there, and another one is one POH bond is here. Okay, its name is ortho, not ortho, hypophosphorus acid. Hypophosphorus acid. Its oxidation state you can calculate. Here its oxidation state is the +1 oxidation state. Hypophosphoric acid. Hypophosphoric acid, this one. Okay, next one you can see. Next one is H3PO3. H3PO3. Orthophosphorus acid. Orthophosphorus acid. Its structure P double bond O, OH, OH, H. See. Here only one pH bond, two POH bonds and one P double bond O bond. Okay. This is a orthophosphorus. Orthophosphorus acid. Next one, if you see H3PO4. H3PO4. Before that, you try to write its oxidation number. Its oxidation number is +3. How can you calculate? Because it is -2, it is -1, it is -1, this is +1. So that it will become +3 oxidation state. If you calculate by using all surrounded atoms or groups oxidation number, you will get +3. Coming to here, this one is orthophosphoric acid. Orthophosphoric acid. P double bond O, OH, OH, OH. See, this is the orthophosphoric acid. Orthophosphoric acid, this one. If you see all these three acids, which one is basic and which one is going to be more, which one is having more reducing nature? Because here the pH bond is not going to be ionizable, so that basicity character depends upon the hydrogen attaches to the oxygen atom through the to the phosphorus. That means, see here, if you take this one, hydrogen attaches to the oxygen, this oxygen attaches to the phosphorus, so that the basicity of this H3PO2 nothing but phosphorus acid will be the one only, one OH is there, because hydrogen and this hydrogen pH bond will not going to be hydrolyzed. And also one more thing, if pH hydrogens attaches to the phosphorus are more, then that acid will become the more reducing character. So that here two hydrogens attaches to the phosphorus, then we will compare it later. Coming to the basic nature, here two hydrogens are there, so that this is dibasic and this is tribasic. Then if when compared to all these three, which one is the more basic one? This is the more basic one. And if you coming to the reducing nature, which one have more reducing nature? If you see, this one have more reducing nature when compared to this, because here two hydrogens attaches to the phosphorus, here only one hydrogen, there is no. That's what, if hydrogens attaches to the phosphorus are more, that will become the more reducing character. Okay, then coming to next one, H3 not H4P2O5. H4P2O5. This one is the pyrophosphorus acid. Pyrophosphorus acid. Its structure you can see POP. Okay, like this. And another one is OH. Here also OH. See this one. All are OH groups only, not hydrogen atoms attaches to the phosphorus directly. If you see what is the oxidation state of phosphorus here, +3. Here it is the +3. Its name is pyrophosphorus acid. Pyrophosphorus acid. This one is the pyrophosphorus acid. Then you can move about H4P2O6. H4P2O6. This is the hypophosphoric acid. Its name is the hypophosphoric acid. Here phosphorus connects to the another phosphorus and P double bond O, remaining are OH groups. OH. How many hydrogen OH completed? 1, 2, 3, 4, 5 oxygens completed, remaining also OH. See here 4 OH groups are there, remaining are P double bond O groups, and 1 P single bond P is there. Okay, here oxidation state of phosphorus is -1, -1, -2, +5. Its oxidation state is the +5 oxidation state. This is the hypophosphoric acid. Hypophosphoric acid. This one is the hypophosphoric acid. Next one you can see H4P2O7. H4P2O7. This is the pyrophosphoric acid. This is the pyrophosphoric acid. Its structure you can see P, 2 phosphorus atoms connected by a single oxygen atom, remaining OH and double bond O, OH. See 1, 2, 3, 4, 5, 6, 7 oxygens, 4 hydrogens, 2 phosphorus atoms are there. Its name is pyrophosphoric acid. Its name is pyrophosphoric acid. You can see its oxidation state also +5, -1, -1, -2, -1. So its oxidation state also +5 oxidation state. The last one you can see metaphosphoric acid. HPO3 taken N. HPO3 taken N. Its structure if you see, this is phosphorus, this is double bond O, this is OH, and C. This is one unit of HPO3. If another unit connected to this one, the structure become like this. See, this is one unit of HPO3, and also another unit going to be connected to this one, OH. See, this is just like a polymeric structure, and this side and that side also HPO3 units will going to be add. That's what we have indicated here, HPO3 taken N. Here also what is the oxidation state of phosphorus? If you see -2, -2, -1, -1 and -1. Here also +4 oxidation state for phosphorus. Okay, and we already discussed if the oxoacid of phosphorus having more number of hydrogens, then it will become good reducing agent. Suppose if you see, suppose you can see, we already discussed about orthophosphorus acid have 2 hydrogen atoms attached to the phosphorus. So when compared to other acids, it will become a more reducing agent. So Here it is going to be it is going to be reduce silver nitrate to the silver metal. How it is? You can see reaction. 4 moles AgNO3 silver nitrate you can take, and 2 moles of water and 1 mole of H3PO2 hypophosphorus acid, then it will gives you 4 moles of silver metal. See, this is the silver metal. Then H3PO2 will gives you, see, next 4 moles of HNO3 will form, remaining will be H3PO4 will form, H3PO4. It will be reduced and it will be oxidized. This is what orthophosphoric acid. This one is the orthophosphoric acid. We have discussed already. First one hypophosphorus, then orthophosphorus, after that orthophosphoric. This one is the orthophosphoric acid. So here the main content is what? H3PO2 is the hypophosphorus, can reduces the silver nitrate to the silver metal. So that will indicates by this reaction. And one more thing, if orthophosphorus acid going to be heated, what will happen? You can see H3PO3, is it visible? Yes, H3PO3 you can take. This is the orthophosphorus acid. 4 moles of orthophosphorus acid going to be reduced, going to be heated. If it is going to be heated, what will happen? If orthophosphorus acid going to be heated, that will become disproportionate. That means the phosphorus atom present in this molecule going to be disproportionate. So that here you can see 3 moles of H3 PO4 and another one is PH3, phosphorus will form. See, phosphine will form. Here if you calculate oxidation numbers for this one, here H3PO3, what is the oxidation number here? This is a +5 oxidation state, plus 3 oxidation state for phosphorus. Here +5 oxidation state, +5 oxidation state for phosphorus in this one. In PH3 it will have -3 oxidation state, -3 oxidation state. That means at the same, in a same chemical reaction, phosphorus going to be oxidized here, and in the same way in another product phosphorus going to be reduced. That means if any atom going to be involved in reduction and oxidation at a time, that will becomes a disproportionation reaction. So this is about oxoacids and halides of phosphorus, and another one is phosphine. I think you are all understand about this class. If you feel useful and informative, please do subscribe, like and share these videos to your known people. Mention your words in comment box, because that will makes me more energy to give more and more lectures for you. Thanks for watching. We will meet in the next class.